आराम से आराम से.
Lewis dot structures in general do not represent the actual shapes of the molecules. In case of polyatomic ions, the net charge is possessed by the ion as a whole and not by a particular atom.
Do you know that, for example, CO3 2 minus, that 2 minus is for the oxygen atom, right? It's not for the oxygen atom. That 2 minus is for the whole ion. Okay?
It is, however, feasible to assign a formal charge to each atom. The formal charge of an atom in a polyatomic.
Okay, wait. So formal charge क्या होता है? Everyone see here. So first of all, you draw the Lewis dot structure of ozone. Come on, everyone. To calculate formal charge, you have to know the Lewis dot structure of ozone. Come on. O4, O3. Ozone is O3. So distribute. How many electrons you have to distribute? 6 into 3. (18 electrons you have to distribute, and you have to make sure that every octet is complete. Done. So done. Okay, that's okay. That's okay. So 18 electrons. So give 2 here, 2 here. Understood why? Because minimum makes you need a single bond, right? So 4 done. So we are left with 14. We are left with 14, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay. So is the octet complete of every oxygen atom? No, right? This one. Let's say 1, 2, 3. The second one's octet is not complete, right? So that's why make a multiple bond. So it will be, now is the octet complete? 1, 2, 3, octet complete, right? So actually, ozone consists of double bond and a single bond. Yes or no? है ना? एक इलेक्ट्रॉन यहाँ पर 1, 2, 3, 4, 5. अभी देखना how to calculate the formal charge. ठीक है? Overall, what is the charge of ozone? Overall charge. Overall, what is the charge of ozone? No
0.
charge. 0. Okay. So 0. No charge. Correct. Formal charge is for the individual atoms in the Lewis dot structure. समझ में आ रहा है? What is the difference between overall charge and formal charge? जैसे CO3 2 minus में overall charge क्या है? -2. That is not the formal charge. Formal charge मतलब होता है in the Lewis dot structure in the individual atoms. What is the charge? Understood the difference? Write down the difference so that you don't get confused. The difference between overall charge and the formal charge. देखो ओवरऑल चार्ज मतलब होता है जो आयन का होता है आउटसाइड. फॉर एग्जांपल CO3 2 minus. दिस इज द ओवरऑल चार्ज. फॉर्मल चार्ज मतलब होता है इंडिविजुअल एटम्स का क्या चार्ज. अंडरस्टूड? निकालने वाले हम. In the Lewis dot structure, individual atoms, what charges they are carrying. Okay. Now see how to find out the formal charge. What you have to do here is, let's say I want to find out the formal charge of oxygen number 1. Okay? The oxygen which is marked as 1. So what you have to do is, tell me the number of valence electrons in oxygen. 6. It is always 6. So 6 minus what you have to do? How many electrons are involved in bonding or not involved in bonding? देखो, first of all, you tell me how many electrons are involved in bonding for the O1 atom. Everyone, It's 2. Is it 2? Everyone, is it 2? Harshal, is it 2? How many electrons are involved in bonding for oxygen first atom?
So it's 2.
2 है ना, because multiple bond है, 4 electrons are shared, but 2 are given by the O1. So it is -2. And minus how many electrons are present as lone pairs? How many electrons are present as lone pair? How many electrons are present as lone pair in the first oxygen? I will repeat. How many electrons are present as lone pairs? 4. 2 here, 2 here. I am talking about the first oxygen. How many electrons are involved as lone pairs? 4, right? So what is the charge, formal charge on O1 atom? 0. ठीक है, इसका कोई charge नहीं. The formal charge is 0. Okay. Now let's calculate for the O2, the oxygen which is marked as 2. ठीक है? How you have to do? Valence electrons कितना है? 6. Minus how many electrons are involved in bonding? ध्यान से देखो. How is it 4?
So the 3.
2 from here, 1 from here. 3. Or how many electrons are present as lone pairs? 2. So इसका formal charge कितना है? +1. ठीक है? So the formal charge here is +1. So let's calculate the formal charge in the third oxygen atom. ठीक है? So 6 again, 6 minus how many electrons are involved in bonding?
1.
1, because this is a single bond, right? 1, and minus how many electrons are present as lone pairs? 6. So what is the formal charge? -1. So the formal charge here is -1. So one more thing to observe here is the sum of formal charge on individual atoms is equal to the overall charge of the molecule. Are you able to see? Again, I will repeat my statement. The sum of formal charge on individual atoms is equal to the overall charge of the molecule. The overall charge here is 0. And what is the sum of formal charges? O1 में 0 है, plus इसमें +1 है, plus इसमें -1 है. So what is the overall? 0. ये याद रखना हमेशा. I mean, it's also, you know, let's say you have drawn some structure, you have calculated the formal charge. You can use this to see whether you have got the correct answer or not. है ना? Overall charge का बराबर आना चाहिए सबका सम करके. Real? What is this? Oh, then say this. Harshal, clear हुआ? अभी CO3 2- में मुझे बताओ कार्बन एंड ऑल द 3 ऑक्सीजन में व्हाट इज द फॉर्मल चार्ज? कम ऑन. इन CO3 2- टेल मी द फॉर्मल चार्ज. COOO. So wait, I will show you the bonding कैसे होगा. एक डबल बॉन्ड होता है, एक सिंगल बॉन्ड होता है ना.
Which makes 1. The load is carbon and the other ones. So carbon, the ones that carbon might for a triple bond, so there will be relation with carbon. The ones that carbon goes for load pairs are the ones that carbon does not go. Usually crossover voltage, 2 dots go to 2, they are not one. Dots, the 2 lines next to it, that is the bond created.
Q1, Q2, Q3, Q4 बताओ मेरे को.
Look at this lone electron are the electrons which are outside shell dots. Okay. Bonded electrons are the dots which are connected. The electrons are connected. In this case, carbon. Because we have shown that. No, we made it.
Have you revised or not before coming to this class? Wait, Sean. Have you revised or not before coming to this class? Yes or no? After going home in the last class, did you see your notebook again or not? Yes or no? So did you see the recording? Did you ask for the recording? Did you investigate for the recording? Yes or no? This, so you got the answer. कितना आया Q1, Q2, Q3, Q4?
C1 formal charge is 0. O2 formal charge is 0. O3 formal charge is -1. O4 formal charge is -1.
ओवरऑल कितना आ रहा है? -2. तो CO3 में कितना होता है ओवरऑल चार्ज? -2. अंडरस्टूड? Which
So like 1, 2, 3, 4.
Q? Q is for charge. Q is the symbol that you use.
Is it like subscript?
No.
4
It's
of each? No, 4. 1, 2, 3.
no. I mean, I just asked on the fourth atom. 4 means this.
No, I'm saying that you written Q4, right? 4 is in subscript or like next to it?
Subscript. Done. Harshal. Done. Okay. Dhoni done. What the answer? No.
Q1 is charge.
Charge. I mean, formal charge. For,
Charge doesn't.
-2, right? Okay. Okay. Continue. So.
The formal charge of an atom in a polyatomic molecule or ion may be defined as the difference between the number of valence electrons of that atom in an isolated or free state and the number of electrons assigned to that atom in the Lewis structure. It is expressed as formal charge or FC on an atom in the Lewis structure.
Okay. So no need to remember that formula. कुछ याद करने की जरूरत नहीं है. What we have done? Valence electrons minus कितना electrons involved in bonding minus कितना electrons are present as lone pairs. खत्म. ठीक है? Continue.
The counting is based on the assumption that the atom in the molecule owns one electron of each shared pair and both the electrons of the lone pair.
Okay.
Let us consider the ozone molecule O3. The Lewis structure of O3 can be known as this. The atoms have been numbered as 1, 2, and 3. The formal charge on central O marked 1 is 6 minus 2 minus half into 6. We don't have to go back. What do I read this? Hence, we represent O3 along with the formal charges as follows. We must understand that formal charges do not indicate real charge separation within the molecule. Indicating the charges of the atoms in the Lewis structure only help in keeping track of the valence electrons in the molecule.
Okay, wait. So, so what is the application of this formal charges? Okay. So remember, like I told you to draw CH3OH. Let's say, yeah, CH3OH. So this can be drawn in different ways, right? It can be drawn like this. Like if you don't know that it's an alcohol, you can do this. If you know that it's an alcohol, then this is the correct answer. Or you can draw it like this. For example, CHOH. This can also be done if you don't know that it's an alcohol. Okay, and also this can be done. COH. So now your job is, now what you have to do is calculate the formal charge on carbon and oxygen in these three structures, 1, 2, and 3. Calculate the formal charge of carbon and oxygen in these three structures. Come on. Then you will understand and appreciate why do we need formal charge? Why are we calculating formal charge?
Balanced hydrogen is one.
Yes. In the first case, how much you got for carbon and oxygen? 0. In the first case, carbon and oxygen. How can you get?
6 minus 2
What about the lone pairs in oxygen?
minus 4.
2 here, 2. If I have not drawn lone pairs, you should understand that there are lone pairs. Octet needs to be completed, right? So it will be 0 and 0 here. Okay, good. What about in the second case? Second case में कितना है कार्बन का? +1. Oxygen also +1. How much? Is it +1? Let's see. 6 minus 3 minus 2 +1. Okay. Okay. So is it correct then? Is this structure correct? Okay. For carbon, you got +1. Are you sure, everyone?
So how do you get +1 for carbon?
Okay, so it is 4 minus how many electrons are involved? 3. लोन पेयर नहीं होगा ना, क्योंकि लोन पेयर हुआ तो ऑक्टेट से ज्यादा हो जाएगा ना, 2 3 4 5 6. नहीं. Why can't carbon have a lone pair?
It will have a lone pair, right?
Okay, so -2 then you have to do, right?
4. Yeah, it does.
You said it's +1. It will be -1. Okay, what about here? That's what I was thinking. Sum करके 0 आना चाहिए. इधर कितना होगा? 4 minus 2 minus 4. So it will be -2 here and +2 here, because 4 minus 4, no, 6 minus 4, that is +2. Understood, everyone? Yes. Is it clear, everyone? Okay. Okay, now you will appreciate it. Tell me one thing. If in a molecule there is charge separation, okay, so is that molecule stable compared to a molecule which does not have any charge separation? Charge separation in the sense, जैसे देखो -1 +1 का charges develop हो रहा है. So that molecule is unstable compared to a molecule where there is no charges separation. है ना? So out of these three, which one is the most stable structure? The first one. So how did you decide? There are multiple structures, but which one you are choosing? The one which has least number of formal charge. Understood? Why are we calculating formal charge? Because formal charge will tell us what is the charges in individual atoms. तो जितना ज़्यादा होगा उतना unstable होगा वो. So therefore, if multiple structures are possible, choose the one which have less formal charge. Harshal, समझ में आया? Yes. So write that thing down. That is the application of it.
Basically, you can draw any molecule properly.
But there are some exceptions. Okay. Even you will come to know that like noble gases also form compounds. Yeah, xenon. Xenon forms xenon difluoride, XCF2, XCPTF6, those kind of compounds. Okay, so then next we'll talk about limitations of the octet rule. Okay, what are the limitations and why do we need other theories? Limitations of the octet rule. Yes. Dhani. 4.1.5.
There are three types of exception to the octet. Incomplete octet of the central atom.
Write down the first one. Incomplete octet of the central atom. So according to Lewis and Kossel, why were atoms forming compounds? What was the reason? To complete their octet. But we know some molecules in which they are molecules. They have formed a chemical bond between themselves, but they don't have octet. For example, write down LiCl2, LiCl, sorry, LiCl, BeH2, BCl3. Can you draw the Lewis structures of these three? AlCl3 you will understand, and BF3. Draw the Lewis dot structure of LiCl, BeH2, BCl3, and AlCl3. You will understand.
atomic number of electrons? 30.
Like atomic number is 30. Valence electrons is how much? 3.
It's good.
So is the octet complete of any central metal atom? But still they exist. Okay. So this cannot be the answer. This theory is not perfect. If you draw, for example, LiCl में क्या होगा? LiCl will be Li 2 dots here. BH2 में क्या होगा? BH 2 dot 2 dot. Beryllium 1:2:2. What is the hydrogen, helium, lithium, beryllium? 4. 1:2:2, right? 2 valence electrons. So 1, 2 और 2 हाइड्रोजन से आ रहा है. BCl3 में देखो 1, 2, 3, 4, 5, 6. Same thing with AlCl3. Same family क्या है ना? Okay, so none of their octet is getting completed, but still they exist. How is this possible? Okay, so read next. Odd electron molecules.
Molecules with an odd number like nitrogen oxide, NO and nitrogen dioxide, and the octet rule is not satisfied for all the atoms.
Okay, so now draw the Lewis dot structure for NO and NO2. Come on, everyone, and show the formal charges in them. Draw the Lewis dot structure for NO and NO2.
That's fine.
Yes. Is it 3 nitrogen? It's 5. If you have confusion, write down the configuration. Atomic number is 7, right? 1s2, 2s2, 2p5. So 2s2, 2p5. दोनों outermost shell में है. तो 5 और 2 7 हुआ ना? Sorry, 1s2, 2p3 होगा. Sorry, so 3 plus 2 5. Got it? So what are the formal charges in NO? Okay. What are the formal charges in NO2? NO2 may be 0, 0, 0. And are you able to complete their octet? No, right? Are you able to complete their octet? Okay. NO2 में 000 कैसे आया देखेंगे. NO में how many are there? 5 plus 6, 11 electrons, right? So N or O, sorry, NO, I'm talking about NO. 11 electrons, right? So give 2 here, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. So 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. So you can, like, what you can do is you can make a double bond also here. So then it will be 4, 5, 6, 7, 4, 5, 6, 7, 8. So this will be the structure. Okay. N double bond O, 1, 2, 3, 4, 2 electron, 1 यहाँ पे. So calculate the formal charge. Formal charge क्या होता है? 5 minus how many electrons involved in bonding? 2 minus 3 lone pairs. 0. नाइट्रोजन का 0 है और ऑक्सीजन का देखो 6 minus 4 minus 0. ठीक है. So formal charge दोनों में 0 0 है, but in nitrogen there is a odd electron. Are you able to see? So इसका octet complete नहीं हो रहा है. Still it exists. Still it is existing. This is what we are trying to say. Okay. And next we have NO2. NO2 का कैसा होगा? नाइट्रोजन और ऑक्सीजन में who is the having lesser electronegativity? Electronegativity increases from left to right. Just remember it like that. So nitrogen, I mean फ्लोरीन का सबसे ज्यादा, फिर ऑक्सीजन, फिर नाइट्रोजन, ऐसे होता है. Remember that. Okay. So nitrogen has lesser electronegativity. ठीक है. तो 2 इलेक्ट्रॉन यहाँ दे दो और नाइट्रोजन में 5 होता है plus 6 into 2. 12 और 5 17. Okay. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 और यहाँ देना पड़ेगा obviously because octet complete करवाना है. So 2 3 4 5 6 7 8 2 3 4 5 6 7 8. So this will be the structure of NO2. Okay. Can we do one thing, like can we bring make one multiple bond on both sides?
So no,
4 8 9 वो octet से ज्यादा हो जाएगा. 4 5 6 7. We can do this. दोनों साइड में नहीं कर सकते. Then it will be 4 plus 4 8 plus 1 9. है ना? If we do this one, then see the number of electrons in nitrogen. 9. उतना nitrogen doesn't have that many empty orbitals. 9 it cannot accommodate. अगर नाइट्रोजन के नीचे कौन सा एलिमेंट आता है? फास्फोरस होता तो we can do this. फास्फोरस because 3D आ जाता है. फास्फोरस में 3D आ जाता है ना? ठीक है. So you can bring 1. Okay, so the structure will be N double bond O 1 2 3 4 O single bond 1 2 3 4 5 6 और यहाँ पर एक इलेक्ट्रॉन इसके पास. So calculate the formal charge. कितना होगा? 6 minus 2 3 4 5 6 7 2 3 4 5 6 7. तो यहाँ पे होगा -1. यहाँ पर कितना होगा? 5 minus 2 3 5 minus 2 3 minus 1 will be +1. और यहाँ पर कितना होगा? 6 minus 4 minus 2 0. ठीक है. देखो -1 बचा जाएगा. चल बोलो.
Which oxygen atom is 0? Which
The
one?
oxygen which is doubly bonded to nitrogen.
Alright, that's 0. Definitely.
That's 0. Okay, so these are you able to see a odd electron in nitrogen? Its octet is not complete, but still that molecule exists. Okay. So again, let's go back. What we are discussing about the exceptions of octet. Key molecules, we know some molecules whose octet is not complete, still they exist. पहला हम लोगों ने देखा BeH2, AlCl3 इन सब के बारे में. Second हम लोगों ने देखा कि they have an odd electron with them. ठीक है. And third वाला देखो. There are 3 exceptions. The expanded octet. Okay, so wait. So I will tell you the difference between a second period. देखो, let's talk about nitrogen का कौन सा family है? 15 है, ठीक है? Sorry, group 15, ठीक है? और second period में और third period के एक element में मैं difference बताऊंगा. In group 15, second period, which is the element? Nitrogen. Group 15, nitrogen, and uske niche phosphorus. Okay. So I will tell you what is the difference between these two. Although they belong to the same family. You remember I told you the first guy in the second period, or you can say the first guy in a particular family is different from the other guys. Okay. Why is that? Because if you see the configuration of nitrogen, what is its configuration? 1s2, 2s2, 2p3. ठीक है? 2d हो सकता है. Is 2d possible? 2d possible नहीं होता. Do you know that? Huh? Okay. But in third period, so it is 1s2, 2s2, 2p6, 3s2, 3p3. Is this correct? 15 electrons है ना? अब देखो 3 में 3d भी हो सकता है, 3d orbital भी हो सकता है, but वो 0 है. But there are 3d orbitals, so it can accommodate more electrons, but it cannot accommodate more electrons. समझ में आ रहा है? Okay, continue. Okay, so for example, you see PF5 and PF5. ठीक है? तो PF5 is like this. देखो Cl, 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 Cl और एक Cl. देखो how many electrons are surrounding phosphorus?
So 10.
10. It's more than the octet, right? How is it achieving that? Because of these guys. 3D में वो accommodate कर सकता है. समझ में आ रहा है? लेकिन nitrogen will never form NF5 because nitrogen के पास है ही नहीं. They don't have orbitals, empty orbitals. Is that okay? Why nitrogen can't form NF5 but phosphorus forms NF5? Is that okay, everyone? Okay. So there are some more examples. For example, you can see SF6. You can see H2SO4. देखो example देखो. SF6 में how many electrons are surrounding sulfur? 12. And in H2SO4, how many electrons are surrounding sulfur? Okay. So these are the 3 exceptions. First is sometimes they have electrons lesser than 8. Second is odd electron. In odd electron species, octet is not complete. In the third case is sometimes they have more than the octet. Okay. These are the 3 exceptions. Is it okay? Everyone understood? Understood? Okay. Go to 106. Other drawbacks of octet theory से पढ़ो. XCF2. अब देखो their whole theory, Cosell and Lewis का पूरा theory was based on कि inert gas, everyone wants to achieve inert gas. देखो problem क्या हो, inert gas खुद compound बनता है, so ऐसा I mean full damage to their reputation. They told that कि they don't form any compounds, but they are forming compounds. And there is a reason. I just researched it today. Why they form compounds is देखो what happens as you go down a group. What happens to the shielding effect? As you go down the group, what happens to the shielding effect? Increases or decreases? Shielding effect increases. Why does it increase? More electrons in between the outermost shell and the nucleus. ठीक है? अभी देखो तुम नियॉन, वहां पर देखो हीलियम, नियॉन, आर्गन, क्रिप्टॉन. जैसे हम नीचे आ रहे हैं, the shielding is increasing. So let's say I'm comparing helium, I'm comparing neon, and let's say I'm comparing xenon. ठीक है, ध्यान से देखो, why they form compounds. This is the nucleus, this is the nucleus of xenon. ठीक है, अब देखना between nucleus of neon and the outermost valence electron, obviously there will be 8, right, valence electrons. 8 होंगे ना सबको मिला के, है कि नहीं? 1 2 3 4 5 6 7 8. So the in between the valence electrons of neon and nucleus there are how many electrons? Between nucleus and neon, valence shell of neon, 1s2 2s2 2p 6 होता है ना, so 2 इलेक्ट्रॉन है ना, 0 कैसे? This is the valence shell, so there are 2 electrons here which is shielding the outermost electrons from the nucleus. Here obviously it will be more than 2, right, because उसका atomic number 54 है शायद xenon का, होगा कुछ, obviously it will be more than 2, right? So देखो shielding increase हो रहा है, so that's why the valence electron of xenon is not under a lot of influence from the nucleus because of shielding of by the electrons here. So that's why it can give away its electrons.
It's not holding the electron.
It's not holding the electrons that with that strength because the shielding increases down the group. Okay, so although inert gas are supposed to be inert, but they are little bit reactive.
So basically the later electron.
The last ones, krypton, xenon, radon, ठीक है, these are unstable also. समझ में आया? So that's why they forms compound like ZeF2 because xenon एक इलेक्ट्रॉन इजीली यूज कर लेगा और फ्लोरीन एक इलेक्ट्रॉन इजीली एक्सेप्ट कर लेगा, है ना? So this is the reason. ठीक है, कंटिन्यू. ऊपर second point you listed doesn't talk about anything about the shape of molecules. For example, H2O. अभी जैसे हम Lewis dot structure बना रहे हैं, every molecule should be linear, right? We are drawing them on a plane. Every molecule should be linear. H2O linear नहीं है. H2O is bent. There is a difference between bent and linear. ठीक है? Okay. Continue.
It does not explain the stability of the because it's silent on the energy.
And do you remember when we were discussing chemical bond, we said that why does atoms are forming molecule? Because atom का energy मान लो 10 है, तो molecule जब वो बनता है उसका energy कितना हो जाएगा? 5 होगा, कम होता है. So about this thing they are not saying anything. Okay, so these are some of the limitations. याद रखना है. Okay, ठीक है. What's your name? Yes, continue. Ionic. So we are going to talk about ionic bond in detail. ठीक है? Ionic bond. It's one second. Ionic bond or electrovalent bond. Okay, wait, just a second. Let me see. So whenever you form ionic bond, there are 3 things involved. ठीक है, दिमाग में रखना है. पहला क्या होता है, जैसे मान लो NaCl की मैं बात करता हूँ. Whenever we get NaCl, how do we get NaCl? देखो Na क्या होगा, अपने gaseous state में एक इलेक्ट्रॉन लूज करता है to become Na plus gaseous, है ना? This is the first step. So what is the energy involved here in this process? What is this known as? We have learned this.
Ionization.
You are removing the valence electron, ionization enthalpy. Yeah, ionization energy. ठीक है? So the energy involved in this process to do this is known as ionization enthalpy. So this is the first step. तो मुझे बताओ ionization energy ज्यादा होना चाहिए कम होना चाहिए ionic bond बनने के लिए? What is ionization energy? The energy that you have to give to throw that electron out from the influence. So it should be less. So कम energy देने से ion बन गया. So this should be less. देखो ionization energy is always positive. ये पता है ना? You have to give. You have to give the energy. Okay. So it is always positive. And like we want it to be less. Okay. Second क्या होता है? That electron, the electron that was lost by sodium, it will be gained by chlorine. So chlorine will gain 1 electron to become chlorine minus, right? So what is this known as? What is this known as? The energy involved in this. He missed every class. Still he is answering. You guys came in each and every class.
So isn't the electron gain enthalpy?
Hmm. Okay, so this can be positive as well as negative. समझ में आ रहा है? जैसे if you want to add one electron to neon, so there it will be positive because you are disturbing the object, है ना? But if you want to add one electron to fluorine, it will be negative because you are making it, you are fulfilling its object. Are you able to understand? हाँ या ना बोलो यार.
So, but then for like neon, you can even remove an electron. No?
I'm talking about electron gain enthalpy.
Oh.
So what will happen is,
What will happen to xenon?
xenon is not stable.
Xenon का ionization energy is more, but not that high. If you can देखो ionization energy, if you can provide that much, you can like कोई भी atom का एक electron निकाल सकते. So under critical situations, these things happen. जैसे ZeF2 normally नहीं होता, ठीक है? So what I'm trying to say is electron gain enthalpy. So electron gain enthalpy for neon is positive because the valence electron configuration is 2-8. Sorry, 8. The number of electrons in the valence shell is 8, and you are trying to add one electron. You are disturbing it. So you have to give the energy. But for neon, so for fluorine, it is negative. Negative मतलब energy release हो रहा है. कब release होता है? When it becomes something stable, है ना? तो fluorine में तुमने एक इलेक्ट्रॉन लगा दिया, तो 7 से उसका 8 हो जाता है. What is the configuration of fluorine? 2-7, right? Then it comes 2-8. So that's why it is negative. Okay. So you want electron gain enthalpy to be positive or negative? For an ideal ionic bond,
Make an ionic bond.
to make an ionic bond or to get a strong ionic bond, should be positive or negative? देखो, I have told you repeatedly, chemistry में energy is the currency, and the less energy involved जो तुम दे रहे हो, if the energy is released, very good, very good, excellent. So always we look for release of energy because we don't want to give energy. उसमें अपना loss है ना, selfish. So we want it to be negative. Overall हमें negative चाहिए, हमेशा याद रखना. If you are doing any process in chemistry, overall energy should be negative. Any process. अभी thermodynamics में जाके पता चलेगा कि कोई भी process कब होता है. When does a reaction happen? When the change in energy is negative. जैसे तुम लोगों ने पढ़ा होगा H2 plus O2 gives H2O. ये एनर्जी कब पॉसिबल है? जब फाइनल H2 जो मिल रहा है उसका एनर्जी इज लेसर देन H2 and O2, whatever you have. So we want this to be negative. If it is highly negative, we are very happy. ठीक है? तो अभी अगर डेटा हम लें, so अभी देखना डेटा मैं बताता हूँ एग्जैक्ट डेटा. So the ionization enthalpy is, this energy is plus 495.8 kilojoules per mole. Per mole मतलब समझ में आ रहा है ना? एक मोल को you have to give this much energy. So this is the exact value. It is in positive, right? The exact value. और इसका exact value देखो delta Eg का है -348.7 kilojoule per mole. है ना? दोनों को ऐड करो कितना आएगा? पॉजिटिव आएगा, नेगेटिव आएगा, बताओ.
Yes.
टोटल एनर्जी पॉजिटिव आ रहा है ना? है ना? That means बॉन्ड क्यों बन रहा है? एनर्जी शुड बी रिलीज्ड, राइट? टोटल एनर्जी नेगेटिव आना चाहिए, दोनों को ऐड करके. इसका देखो प्लस 495.8, इसका है -348.7, है ना? तो अभी देखना, we have missed the third step. When we form ions, अब देखो ions attract होते हैं ना, है कि नहीं? So next step is Na plus Cl minus will attract each other and they form a regular lattice structure. Do you know that? I have told you. So they form NaCl
Connect to the 6.
lattice structure. NaCl exist कैसे करता है? I will show you again. If you see one cube of NaCl, so actually how does it exist? And what is the meaning of lattice? तो ये जो white color के these are Cl minus ions and the red color guys are Na plus ions. So this is the lattice of NaCl. NaCl कैसे exist करता है? समझ में आ रहा है? एक regular structure में होता है. And do you know solids? The property of solids. They have a definite shape. Definite shape ये क्या है? समझ में आ रहा है? So if you see here, if you see any Na plus, how many Cl minus is around it? At equal distance. 6. कैसे बताऊं? ये 1, ये 2, 3, 4, 5, 6. So each Na plus is surrounded by 6 Cl minus. Similarly, if you take 1, right, this will be surrounded by 6 Na plus. समझ में आ रहा है? अगर मैं ये लैटिस ऐसे कंटिन्यू करूं पीछे साइड में, okay, so it is continuous. ऐसे continuous structure होता है. So when they form this particular very arranged structure, they release a huge load of energy. That is known as lattice energy. ठीक है? तो इसका amount होता है, देखो, lattice energy is, अभी लिखना मत, पहले देखो इसको. So it is minus 788 kilojoules. First step क्या था? Na ने अपना इलेक्ट्रॉन लूज किया, plus you have to give energy. Cl minus gained it, energy released. और third step में, when Na plus and Cl minus came, and they formed a particular lattice, arranged ordered structure. So they release minus 788. अभी total calculate करो कितना energy release हुआ या gain हुआ? Adding all of them. Negative. समझ में आया? Why are we getting ionic bond? Overall energy कम हो रहा है. So 3 things are involved here: ionization energy, electron gain enthalpy, and lattice energy. ठीक है? समझ में आया हर्षल? You still? So it is. So there are 3 steps, right? After formation of Cl minus and Na plus, what happens is Na plus and Cl minus, they attract each other and they occupy regular fixed positions. So these lines does not exist. I am just showing it. These lines does not exist. I am just showing it to show you that they are forming a regular cube-like structure. So they surround themselves. I mean, जैसे एक Na plus के surrounding पे देखो 6 Cl minus होता है. So because of this regular formation of a lattice, energy is released. समझ में आ रहा है? देखो, एक लिक्विड से जब हम सॉलिड स्टेट पे जाते हैं, एनर्जी रिलीज होता है या गेन होता है? लिक्विड टू सॉलिड एनर्जी गेन होता है या एनर्जी लूज होता है? we cool it, right? एनर्जी रिलीज होता है ना? क्यों? कहां का एनर्जी है? लिक्विड पार्टिकल्स have more degree of movement, and when they are ordered in one place, एनर्जी कम हो गया, so that energy is released here. That's what is lattice energy. Understood? पहले यहाँ ऐसे हो रहे थे, फिर अभी रेगुलर एक पर्टिकुलर पोजीशन मिल गया सब लोग. So that is known as the lattice energy. ठीक है? So 3 things are involved. Understood? Understood, Priyan? ठीक है, कंटिन्यू, अभी कंटिन्यू करो. हाँ, राइट करो, राइट. Go back, Simon. You don't want this, right? Okay, so your mom was asking about reference books, right? So here what we do is, like, the theory part we do from the NCERT, that's, which is more than enough, I think. And questions we do it from, there is a book, I will give in the group. After you're added in the group, I will share it. I gave it to you guys, right? I gave you one book, no, Arihant, याद है? Solve करने बोला था, किया? I gave you in the group.
Will you give test it?
Okay, like from test paper, I remember your physics papers are checked. It's there. When did you?
Sir, posted the marks.
No, you can check your paper.
Posted.
Yeah, it's correct. Chem, he told me to, yeah, give it to you guys. Chemistry आज नहीं कल. ठीक है, I will खत भेज दूंगा. No.
Sir, and posted change.
Where is my payment?
So my favorite. So can you take mine?
Where is my payment?
I have done in my
No, like you want special preferences, right? Where is my?
So I have 10 rupees in my.
Oh,
That's all the bus. So can you please check it out?
I will share your marks to your mom, not you.
That's also fine. You know that with that. That's fine. You know that I've been done.
So middle of lattice for
Energy. I mean, this is the lattice structure. देखो और एक चीज है, जैसे एक चीज को बनाने के लिए मान लो 500 किलोजूल चाहिए, तो to break that thing also we need how much energy? 500 only, right? ये आदत नहीं है वाला चीज. Done. Okay, continue.
Ionic or electrolytic bond. From the fossil and English treatment of formation of an ionic bond, follows that the formation of ionic compounds would primarily depend upon the ease of formation of positive and negative ions with the respective neutral atoms, the arrangement of the positive and negative ions in the solid, that is the lattice of the crystalline compound. The formation of a positive ion involves ionization, that is the removal of electrons from the neutral atom, and that of the negative ion involves the addition of electrons to the neutral atom.
M gaseous state forming M plus gaseous state plus electricity.
N gaseous state is raised to N plus gaseous state plus electron. X gaseous state plus electron is raised to X minus gaseous state.
So that's the So the first one is ionization enthalpy. ठीक है? दूसरा वाला क्या है? Electron gain enthalpy. And continue.
Plus gaseous state plus X minus gaseous state is raised to Mx plus.
Understood? Na plus और Cl minus coming together and forming NaCl. देखो NaCl actually वो नाम गलत है. Because NaCl from that you don't. देखो NaCl में लोगों को लगता है कि it consists of Na and Cl. The way in H2O you have HOH है ना? But in NaCl you don't have NaCl. You have Na plus and Cl minus. You understand? So that's, I mean, that's not correct. Huh? Why do this? See, because they want us to understand that it's, I mean, हम लोग को खुद दिमाग लगाना है. कि it's an ionic compound. और एक बात बताओ, जैसे for common people, will they say Na plus? Give me Na plus Cl minus. ऐसे नहीं होता ना. Continue. Continue.
The electron, the electron gain enthalpy is the enthalpy change given when a gas phase atom in its ground state gains an electron. The electron gain process may be exothermic or endothermic. The ionization on the other hand is always endothermic. Electron affinity is a negative of the energy change accompanying electron gain.
Okay, so एक और चीज मुझे बोलना था कि the what is electron affinity?
One big electron.
Huh?
One big.
And what is electron gain enthalpy? Huh? So like we know this thing, right? Delta E Eg. We know this thing, right? So ये देखो ये जो term है, I mean this जैसे मान लो अगर delta, so it can be positive or negative. Let's say for fluorine it is negative, right? Let's say it is minus 500. So the E affinity, electron affinity will be plus 500. Plus 500. It's just the reverse of this sign. That's it. समझ में आ रहा है? एक नया term है, which is just the reverse of electron gain enthalpy in terms of sign. That's it. Don't get confused. It's the same thing, but sign reverse कर दो. जैसे अगर फ्लोरीन का -500 है इलेक्ट्रॉन गेन एंथैल्पी, तो इलेक्ट्रॉन एफिनिटी कितना होगा? +500. अगर मान लो नियॉन का, if the electron gain enthalpy of neon is +200, तो इलेक्ट्रॉन एफिनिटी will be -200. Simple. Just एक term है वो. Don't get confused. Electron affinity.
We say electron affinity plus electron gain enthalpy.
वो नहीं बोल सकते, थोड़ा सा डिफरेंस है, लेकिन for now okay. Okay, continue.
Obviously, ionic bonds will be formed more easily between elements with comparatively low ionization enthalpies and elements with comparatively high negative value of electron gain enthalpy.
Okay, this everyone write down. This you should write down. This I have already told you, but write it down again. Whose phone is this? Yours, right? हो गया? Everyone, continue.
Most ionic compounds are cations derived
Wait. Okay. So अभी देखना ionic compounds में. Let's say, I mean, okay. So ionic compound will consist of a cation and the anion. Is that fine? है ना? So let's say cation and the anion. तो cation मतलब क्या होता है? The guy who has lost its electron, right? The guy who has positive charge. Okay. So who will form the cation in the periodic table? which block is measured, they are going to form cations in the periodic table. Come on. देखो cation बनने के लिए इलेक्ट्रॉन लूज होना पड़ता है ना, तो those elements whose ionization energy is less, so they will easily form cations, right? So in which block has the least ionization energy? Why are you not able to tell me, you both of you? तुम दोनों 6 classes मैंने इसमें इन्वेस्ट किया है, अगर ये नहीं बता पा रहे हो तो क्या फायदा फिर?
Could you repeat the question?
The question is which element, which block in the periodic table will most easily form cations?
Cations.
That means they will most easily lose their electrons.
Oh,
Who
that
lose-
would be alkali metals. Right?
Alkali and alkaline earth metals.
Yeah.
What are the characteristics of a metal? They lose their electrons easily. They have free electrons, right? Why are they good conductors in electricity and heat? Because of those free electrons. They can easily form cations. So that's why most of the cations are from the first and the second group. Check. Have you seen ionic compounds? NaCl, CaCl2, CaOH twice, NaOH, Na2SO4, S block. Okay? So most of the cations are from group 1 or group 2. And from where will be the anions? Then, P block. The anions will be from the P block. क्यों? बताओ क्यों? Yes. So anions, they want electron. They get one electron. So who wants electron desperately? Who is the desperate guy here? The P block, especially fluorine, because they have 7. They want one more just to complete their object. So that's why most of the anions are halides. For example, Cl minus, Br minus, I minus. Okay.
So which group is halogens?
17. Halides are the negative ions. Fluorine, bromine, iodine, these are halogens. When they gain one electron, they become Cl minus. These are known as halides.
Also the entire group 17
Ions, anions, collectively known as halides. The way O2 minus is known as oxides. है ना? Okay, so most of the ions are going to be from group 1, group 2. Most of the cations are going to be from group 17 or group 16 also, because they want 2 electrons. MgO, CaO. Okay, but there is one exception here. That exception is cation is NH4 plus. Have you heard of ammonium chloride? So ammonium chloride is NH4Cl, right? So here what is the cation? NH4 plus. It is made up of cation NH4 plus and anion Cl minus. Are these things new to you? No, right? So NH4 plus में देखो, the cation is made from non-metals. Nitrogen is a non-metal, hydrogen is a non-metal. Exception है ना? Cations are mostly metals, but here both are non-metals. Are you able to see? है ना? तो लिख लेना है. An exception is NH4 plus. This is the ammonium ion.
What is the exception?
NH4 plus. All the cations are supposed to be metals. Lekin the cation ammonium NH4 plus, it has both as non-metals. Done. Continue.
Most ionic compounds are cations derived from metallic elements and anions from non-metallic elements. The ammonium ion NH4 made up of 2 non-metallic elements is an exception. It forms a cation of number of ionic compounds. Ionic compounds in the crystalline state consist of orderly 3-dimensional arrangements of cations and anions held together by Coulombic interaction energies.
Okay, so do you know this Coulombic interaction energy? Do you know that? Okay, so There is a guy, no. So do you know about Coulomb force? What is it? Okay. So do you know gravitational force between two particles is G m1 m2 by r square, right? In a similar way, if you keep two charges, let's say Q1 Q2 मान लो, दोनों प्लस मान लो, तो दोनों रिपेल करेंगे ना, है ना? तो they will go in opposite directions. The force with which they repel each other is given by F is equal to K Q1 Q2 by r square. It follows similar law to gravitation. Similar है, Coulomb. So this is known as Coulomb force. The way attraction between two bodies is known as gravitational force, it is known as Coulomb force because this was given by Coulomb. The guy's name is Coulomb. ठीक है? So K is a constant. 12th में पता चलेगा क्या है? It is 1 by 4 pi epsilon naught ऐसे होता है. वो physics में पता चलेगा. Q1 and Q2, the product of two charges, and r square is the distance between them. ठीक है? So whenever there are charged species, जैसे Na plus हो गया और Cl minus हो गया, तो इसमें attraction होगा या repulsion? Attraction होगा ना, opposite charges. So the force involved here is known as Coulombic force, and the energy involved are known as Coulombic energy. समझ में आ रहा है क्यों? Because charged species are there. Okay, continue.
These compounds crystallize in different crystal structures determined by the size of the ions, their packing arrangements, and other factors.
Wait. So there is a proper. तो एक चीज में ध्यान से सुनना. In the solid state, let's talk about the solid state. Everyone, देखो, concentrate here. Let's talk about the solid state. So solid state में what are its properties? Most important property. Definite shape and volume, है ना? And the molecules have the most amount of attraction, right? And the least distance between them, right? So in the solid state, there are definite arrangement of atoms. Definite arrangement of atoms. So we know, I mean, so we can tell what are these arrangements. We can divide this arrangement into different types. जैसे मान लो अगर जैसे जिंक हो गया, ठीक है? जिंक एटम, जैसे जिंक का एक ब्लॉक उठाया ना, तो जिंक के ब्लॉक में एटम्स ऐसे होते हैं, ऐसे टच कर रहे होंगे. एक्चुअली एटम्स ऐसा होता है, 1 2 3 4. समझ में आ रहा है? बट आई एम शोइंग इट इन अ फॉर्म ऑफ अ क्यूब. ऐसा क्यूब होता नहीं है. आई जस्ट वांट टू शो यू. आर यू एबल टू अंडरस्टैंड? ये सब लाइंस कुछ नहीं होता, बस एटम्स होते हैं. बट आई एम ट्राइंग टू शो यू द परफेक्ट अरेंजमेंट. आर यू एबल टू अंडरस्टैंड? सो यहाँ पर और एक एटम होगा, यहाँ पर और एक एटम होगा, यहाँ पर और एक एटम होगा. समझ में आ रहा है? ऐसे पर्टिकुलर अरेंजमेंट होता है. सो दिस पर्टिकुलर अरेंजमेंट इन सॉलिड स्टेट is this is known as a crystal. The particular definite arrangement that particles attain in the solid state, that is known as the crystalline arrangement. Okay, so this again you are going to learn in class 12 chemistry. First lesson ही आएगा. We are going to learn about the solid state. ठीक है? Continue.
The crystal structure of sodium chloride NaCl and oxide, for example, is shown below. In ionic solids, the sum of the electron gain enthalpy and the ionization enthalpy may be positive, but still the crystal structure is stabilized due to the energy released in the formation of the crystal lattice.
समझ में आ गया? है ना? Lattice, when they are coming closer and forming a lattice, huge amount of energy is released. ठीक है?
For example, the ionization enthalpy for Na gaseous state formation from Na is 495.8 kilojoule by mole.
Per mole, हाँ, by mole भी चलेगा.
While the electron gain enthalpy for the change chlorine gaseous state plus electron possession chlorine is minus 348.7 kilojoule per mole only. The sum of the two, 147.1 kilojoule per mole, is more than compensated for by the enthalpy of lattice formation of NaCl minus 788 kilojoule per mole. Therefore, the energy released in the process is more than the energy absorbed.
Understood? Overall energy release होना चाहिए. ठीक है? Continue.
Thus, a qualitative measure of the stability of an ionic compound is provided by the enthalpy of lattice formation and not simply by achieving octet of electrons around the ionic species in gaseous state.
ठीक है, तो जैसे मान लो you have two ionic compounds A and B है ना, A का लैटिस एनर्जी है मान लो -500 किलोजूल पर मोल और B का लैटिस एनर्जी है -700 किलोजूल पर मोल. Which is stronger and which is more stable? Which ionic compound is more stable? B, right? Because more amount of energy is released. The lattice energy is more. याद रखना है. Lattice energy is used to decide which ionic compound is more stable.
Yes, sir, that is usually more stable.
नहीं, I mean, अगर साइन देखोगे तो ठीक है, but I mean more negative is the value. हाँ, that's okay. Less negative, हाँ, ठीक, lesser the value. But you know, like this sign just tells you that energy released or gained. This doesn't mean कि it's in the negative.
Oh.
Are you getting? This sign
Lesser
is,
energy.
huh?
Lesser energy.
No, I mean this is more energy, but the sign is, don't take it for like in maths. The sign just tells us that it's released. In thermodynamics, negative means released, positive means absorbed. That's it. That's the only role of the sign. Then you have to see the magnitude. Okay. ठीक है, लैटिस एंथैल्पी नेक्स्ट क्लास में करेंगे. ठीक है. Okay, Harshal, bye bye.
Bye, sir.
So